right, so today we're going to start with security. In particular, passwords. If you haven't got... Oh, I remember what I was going to say. So, if you were a professor in a university course, and you offered an online chat room, and somebody came to you the day something is handed out, maybe like an hour later, and said, I'm getting started on this assignment, and I'm having some trouble setting up the environment, getting the libraries installed, or what have you, you'd probably be very, very helpful. If somebody comes to you the night before it's due and says, I'm having trouble setting up my environment, you'd probably be a little less sympathetic. So, word to the wise, life pro tip, the earlier you come for help, the more help you can get. Also, word to the wise, post in the public chat room in Discord. Right? There are several people in this class that are being very, very helpful on that. I will probably give them extra credit because they are being so helpful in the group chat room. I am not online all the time, especially, in the evening. I might be online for like half an hour. I can try to help you quickly if you give a screenshot or something, but I cannot sit there for 2 hours usually and debug with you. Whereas if you post in the public chat room, there's probably 2 or 3 other people online that have gone through what you're going through and can help you right away and quickly. So direct messaging me might work. Definitely if you have something private you want to say. But if it's like, I need help with my code, use the public chat room. That's why it's there. There's lots of people, literally, every time somebody has posted a question, 2 or 3 people have chimed in right away with suggestions. So I will be able to stay, today after class a little bit. Tuesdays I can't come early, but this Thursday I can come a little early. But yeah, ask your coworkers for help. That is definitely much more expedient than waiting for me in a direct message. There are, if you are not finding PyMySQL or Flask in the Raspberry Pi tutorial, it tells you how to install them. If you are running a regular IDE. If you're in Thani, I put step-by-step instructions with screenshots how to install PyMySQL, or one of them, I don't remember. It's the same for both, so if you can do one, you can do both of them. But yes, I will be able to help people get those finished up today. So there's there are 2 ways that are used in conjunction to have security in your applications. There's both database security and there is application security. You should rely on neither one by themselves. They are tools that work together. Database security, like I said last time, never, ever, ever use root for your transactions. It is insecure for many, many reasons, not the least of which is because you don't know who's actually doing the transactions, but you also don't want to give people full administrative access on your entire database, right? Even other database administrators, right? If you are the super user at the pinnacle of your career in a big company, right? You only want individual people to have the access they need, even other systems administrators, right? You only use root to set up other people's user accounts, and then you give them the access that they need to do their job. So you can have separate roles. So in the database, it's not just by user, but you can have a role, right? You can have a role such as systems administrator that has more access, can do more sort of changing of the tables, changing columns, changing data types, and then you can have other rules like a user, which can still insert, update, delete, do all those things, but they can't change the structure of the database itself. So you can put 10 different people in each of these rules, and you can actually just give people more than one role, right? So if somebody is a library customer, they probably shouldn't be able to add books to the library. But if somebody works at the library, they can add, they can delete, they can do whatever. And you can have 10 people working at the library and millions of people reading books, just reading the data. And sometimes you can have people with multiple roles. That's fine. Hey, look at that. Right? There may be there are at Mayo very, very strict legal considerations on who can see what. You do not want to have people even have the possibility of seeing things they're not supposed to. So this is something, legal considerations that you probably want to enforce in both the database and the application. Because if your company can be, closed down because you're doing illegal things by accident, you don't want to allow those things to happen. Multiple ways of stopping illegal things is a good thing. The nice thing about database access permissions is that it is universal to all the access, right? So if I say all librarians have this set, oh, wait a minute, I forgot to say librarians can add books to the library. All I have to do is go into the database and say, add this permission, and immediately all librarians can do that, right? Which is really nice. If I do it in application, every application that uses that database now has to be updated. So the nice thing about database permissions is I can do it once and it changes it for everybody using that database. It's universal and it's easy to update. I just go in and change it and it's done. You can get as crazy as you want with database security. So like we talked about last week, if you want to have specific views where one group of people can just see specific fields from different tables, but not the entire tables, right? You can create a view just to do that and assign permissions to that. You can run stored procedures. We're going to get to that next week. You can, create virtual databases. You can just have specific tables or whatever. Like you can crisscross however you want. It is super, super powerful. You don't want to get too carried away with that, though. And I'll talk about that in a minute. But you can literally go down to like individual records and columns and be super granular with your security. It also makes auditing a lot easier because everything in a database is logged, right? Like everything in the database is logged. So you can see exactly who did what permissions they had, what they're allowed to do, what they're not allowed to do, what they tried to do, what they were allowed and denied from doing. So everything is really nicely laid out. The problem is, right, you might get bogged down trying to create too many roles. So how many is the right number? How much permission should I give? Do I want to, have every single person have their own set of permissions? What's the answer going to be?
Depends.
It depends, right? It's the answer to everything, right? Yes?
I just had a quick question about when you say you can change the permission and it's done in one step.
Yeah.
The people that use that,
Yeah.
That it applies to, would they all get a pop-up that says you need to accept these permissions? Or anything?
No, this is just, when I say permission, I mean like
access.
Access, yeah. When I'm logged in, what can I see and what can I do? So if you'll notice, when you guys log into PHPMyAdmin, you can't see each other's databases. You don't have permission to do it, so it just doesn't even appear. It's like it doesn't exist. Whereas when I log in, I can see everybody's. So you can like go crazy with this stuff, right? Like if you're, again, just to use the library, right? If you have a head librarian and the head librarian is very, very power hungry and says, only I can add books, right? So the head librarian gets their special permission, and then the assistant to the regional librarian says, well, I want to be able to suggest books, and so I get my own special permissions, and then, so it's like you can go crazy, right? Adding special permissions to every single librarian in your library, or you can just say, I have a librarian permission, and if somebody needs something special, I'll just add it to them as a user, right? You don't want to like try to fix every problem with permissions in your database. You can go crazy doing that, because then you can't remember. You'll have your documentation for who can do what will be bigger than the database itself. And one thing to keep in mind, most web applications, so hopefully most of you have heard of the application WordPress. It runs like half the websites in the world these days. Depending on who you ask. If you ask WordPress, it's probably more. But right, WordPress asks you to set up one user which has administrator rights on that database, and then it just stores that information in a PHP settings file and uses that for everything, for users, for administrators, for all these things. So that's less than ideal, but it's not terrible just because of the way you have to go into a web application. Kind of like what we said, right? I don't know if you can see that on the, see that? Hopefully you can see that on that video. A little closer. Right, so here's my web server. Right, you have your database, you have Apache running PHP, right? And so PHP reads this file with your username and password, right? And uses that to access the database. So this user's permissions, if you set it up properly, right, can only be, this user can only log in from localhost. So it can only log in if you're already on this machine. So even if somebody figures out what the username and password is, they couldn't go in to port 3306 like we were doing and use that username and password, because the database would know they're coming from outside and say, no, you have to be coming in locally. You can set that kind of permission in the database. And the other thing is, the only access, I mean, presumably you would block this anyway. The only access is through port 80, which is the regular web port. And when you try to look at this file, right, all that comes up is like an HTML file. It doesn't actually show you the username and password because it's going through PHP. Right, so the PHP interpreter is making sure that nobody can see the username and password stored on your machine. So I think if you were going to make, if you're Amazon.com or if you're a bank or something, you're not going to probably use this methodology of just storing the username and password in a file and reading that with PHP. But for like my blog about cats, right? Who cares if somebody gets in and changes my cat pictures, right? Like, is it the end of the world? Probably not. So again, it depends. It depends on your use case. This makes it really easy for web applications to run. So application security, right? You are still limited by what the database says you can do, right? So application security is setting up users to be able to do certain things, but you still have to log in the database to do those. So if I create this brand new app on my phone to look at Rochester Public Library, right? If I have a menu and my menu doesn't have add a book in it, I can't add a book, right? That's application security. If I can't, there's no way to delete a book in the application, then it doesn't matter what the database user can do if there's no delete function in my application. The application is limiting what I as a user can do. On the other hand, if I should be able to add or delete a book in my application, but my database user that I'm logged in as, the application user, can't do that, then it's just going to error out. So it's kind of a double-edged sword, right? You need security on both, but sometimes they can bump up against each other. So you need to have good documentation. And this is the hard part, right? How do you maintain, like if I have a website for the library, I have an app for the library, maybe I have, the librarians have not a physical, but like a local GUI that, can you just turn it off, maybe, please? Thanks. Maybe the librarians have a Java app or something that they use that was made 40 years ago. Right? So how do I maintain a consistent user policy across all these different apps, across all these different teams? Right? It's kind of easier to do it in the database, set it once, and then the applications can only do certain things. But if I log in as a librarian versus logging in as a client, right, I still want to be able to only see what I should be able to do. So you still need application security, but it's just hard to keep it consistent across all, now that there's 10 different ways to do everything. Right? So like the example on the last slide, if there's a single app, it's easier to maintain, but then you only have one user, and if somebody finds that out, it's again, double-edged sword, right? It depends on your use case. If it's cat pictures, who cares? If it's a bank, you probably want more than one user. This is important as well. So despite all of us wanting to make the perfect database and the perfect app, there are always business considerations, right? So if I make an app for my food truck and all of a sudden, my food truck maybe not explodes, gets really popular, right? All of a sudden I have food trucks everywhere. My business logic really changes because I need to add location as well as delivery as well as this and that, right? So it's a lot easier to do that in the app itself than to try to figure out security in the app and security in the database and keep those together. And you have your database administrator yelling at your developers and blah, 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 blah. So if it's just business logic, right, it should be in the app. So yes, it would be hard to coordinate across a website and an app and a blah, blah, blah. But if it's business logic, business security, it should probably go in the app itself. So, because it's just easier to keep that in one place. And it's easier, ideally you don't want to have the developer and the database administrator constantly having to change things to match each other, right? The database should have administrator, librarian, client, 3 roles, something like that. And then the developer can do all this other fancy stuff in their app. You shouldn't have to be constantly changing stuff in the database because the app wants to do something different, right? So separating those out into logical pieces, again, I don't have a hard and fast rule because, again, it depends on what you're trying to do. But you want to try and separate out what the developer is doing and what the database administrator is doing. Right? It should be logical. That's the bottom line. Obviously, they still need to cooperate, and we're going to talk about storing passwords shortly. Things you have to consider if you're a database administrator: physical security, right? If somebody can walk up to your computer, stick in a thumb drive and copy it, right? It doesn't matter how secure your password is, right? And I don't recommend you try this, but literally you walk, you put on a yellow vest and hold a clipboard, and you can probably walk into most rooms in any business, right? So you send 1,000 emails to 1,000 employees with a malicious link in it, right? Even if it's just 0.1% of people click on that link, you're in, right? More than 90% of malicious attacks on computers these days are not hackers hacking in through the firewall. It's an employee clicking on a link, right? That is why Mayo actually, I don't know if you guys know this, but they send out fake phishing emails to their employees. And if you click on the link, you are sent to re-education camp.
They're kind of funny.
Yeah. But they're serious. I mean, they take it seriously because I don't know if you guys have heard, but several hospitals have had have been held hostage, right? They encrypt they send an encryption virus through all the computers. So if you're a hospital administrator and all of a sudden you can't read any patient records, are you going to spend a week recovering all that data from backup, or are you just going to pay the $10 million so you can actually save people's lives? Right? So that's why Mayo takes, phishing and spam, there's all these different words for it, but basically bad malicious emails really, really seriously, because that's how most attackers get in now. Yeah, no kidding. So firewalls, obviously you don't want to allow port 3306 to be open, even though that's what we're doing, asterisk. Firewalls are kind of beyond the scope of this course, but the premise is the same, right? Lock all the doors and windows first, and then only open the ones you need, right? The premise is make everything too secure and then work backwards. Don't just react to things you think might happen. That's what hardening means. So everything should be locked down until there's a business case to not lock it down, or a use case to not lock it down. This has happened as well, where everything on the company computers are encrypted, and then they make backups and they store them somewhere that are not encrypted. It's like, okay, well, they can't get in the front door, but they can walk to the shed and steal all your money, right? Yeah, this is pretty important. If you have data that needs to be encrypted, it should be encrypted at all times. Only decrypted during use. Don't keep unnecessary data. You have probably heard about this in politics and probably in lots of businesses where they have to keep a certain amount of data for a certain amount of time, and then it is immediately shredded or wiped, right? I don't want to get into the moral issues of this, but from a purely security standpoint, don't keep unnecessary data, right? Obviously, keep your backups of stuff you need, but once you don't need it anymore, get rid of it. Just get rid of it, because what is encrypted and stored today, right, is easily hackable 10 years from now, right? Encryption models are changing all the time, and computers are getting faster, and soon we'll have quantum computers that will render current encryption basically useless. So just because it's encrypted and stored somewhere doesn't mean 10 years from now somebody couldn't just open it up. So if you don't need it, delete it. Again, be stingy about access. Your job is yes.
I was just curious, what's the moral, just real quick?
So there have been cases where a company just starts shredding stuff because it's evidence of their wrongdoing, right? And somebody finds out and requests access, and they're like, "Oh, it disappeared," right? Emails, good example. Be stingy about access. So again, be friendly with your coworkers, not your friends, right? The database is your responsibility, right? If somebody is just like, "Oh, I just need to get this," your job is to say, "Too bad, that's not your job," right? And yes, it kind of makes you uncomfortable, but that doesn't make you wrong, if they need access, just say, hey, yeah, get an email from a boss saying that you need access, and I will be happy to give it to you. But I cannot make that decision. And then automated monitoring software. Once you get beyond a certain size, you cannot read log files. It's not possible. So there's a lot of different options for monitoring software for all kinds of databases out there that are very, very good at alerting you to suspicious circumstances. So everybody uses this now in any kind of large business, because you cannot physically read all the logs of a database of any reasonable sized business. So those are the things you have to keep in mind. And now we get to storing passwords. This is a huge deal. This is a huge deal because, believe it or not, people still store passwords in plain text. Yes. So if you ever sign up for a website and they send you your username and password as a confirmation in an email, you should go to their headquarters and light them on fire. That means that they have stored your password. There is no reason for anyone to ever store your password, and I will show you how shortly. But seriously, if somebody ever emails you your password, delete your account, send an email to their security department, do everything you can to get as far away from that company as possible. That means they have no clue what they're doing. Let me put it this way. Say I am Amazon. I'm sure they do not do this, but so I have my username, which is jbartus. Hey, I use jbartus on most of the sites I visit. I happen to like the name. Password is, fluffybunny123 with an exclamation mark, right? And an underscore or whatever they forced me to do, right? And I use some variation of fluffybunny123 because that's my pet's name on half the websites I visit, right? So nobody can ever guess this because fluffybunny123 is obviously way too secure, but somebody named Mary Smith actually used the password. So now somebody guessed that, went into the database, and now they can read everyone else's password. So even if mine is actually super secure, 5 million characters long, if this company stored it in plain text, somebody else can read it. Right? This is just bad. Nobody that knows anything about databases would ever do this. So please don't do this. So if you must store passwords or other similar sensitive information, I would like you to use the following. First, we're going to use something called a salt. And a salt is a way of just adding a little bit of text to your password so that it is unique. So say my password is hello. So the first thing I'm going to do is on every different website, they should add a little bit of random text to the beginning. So let's say it's random 2, 4, 6, 8. That is called your salt. Then what I'm going to do is I'm going to take this whole string right here and put it through a meat grinder. Called a hashing algorithm. Hashing is a one-way function.
Is your marker in the way?
No, it's above that.
I was thinking
Thanks
that
for checking.
before.
Yeah, that'd be weird. Right? And what this does is it creates this long string of seemingly random characters. Now, what do I mean by one way? I mean something like modulus. All of you remember 6th grade math? Right? Modulus is the percent sign. It means remainder. It is a one-way function. The remainder of 12 divided by 5 is 2, right? But what is the remainder of 22 divided by 5? Also 2. What is the remainder of that? It's also 2. Is there any way to figure out what that first number was based on the number 2? But if I happen to be trying to guess your password, and I guess really close, is that going to give me 2? No. Right? The same number will always give me the same answer, but there's no way to work backwards. That is what a one-way function does. It always works the same in one direction, but you cannot figure out where you started just from the answer. Even if you know this. Right? Even if you know the function itself. Even if I told you the answer is 2, and the function I used is modulus 5, you still couldn't tell me which one of these my password is. That is the definition of a one-way function. So that is what a hash does. A hash, and usually these are 128 or 256, right? But it will take any amount of text at all. If you've ever downloaded an operating system like Linux, right, it'll often tell you to verify against the hash key. Or if you are legally downloading movies from a legal site, right, they will often provide a hash so that you know that somebody hasn't stuck a little bit of malicious hardware or software on the end of it to try and get into your system, right? Anyway, trust me, if you go to like Linux, Ubuntu, or Mint or something like that and go to their download page, they will have the giant file, a few gigabytes, and they will have a little hash key like this. And what they want you to do is run that download through this meat grinder, and it should give you the same number that they told you. That verifies that the file you got is the same file that they put on their website. So now, the really, really cool part about this is all that I store is this little bit of extra randomness I put on the beginning, and I store this bit of random or seemingly random gibberish called the hash in my database. Password is nowhere to be found. I do not store this word ever, anywhere. So the next time I log in, what do? Well, how do I know if my password is right? Well, the user comes in, types hello. I say, okay, well, this user has this salt, 2468. I put it through the same hashing algorithm that I used the first time, and I see, does the output of that match what I have stored in my database? I never need to know your password. It is stored in memory in the app, and that's it. Once you log off, it's gone. Once you turn off your computer, it's gone. I never store this part in my database. I have to store this part, and I have to store this part. But if somebody gets like breaks into my database and gets 2468 and some 256 character string of gibberish, they can't log in. There's literally nothing they can do with that. They would still have to brute force. They would still have to try every single thing until they got, they could add this to every single thing and then run the hash to see if it, matches. That's the only thing they could do. Obviously, there are some sophisticated crackers that can do some things on this, but fundamentally, there's nothing they can do with just this salt and this number. You do not store, there is no reason to store a password in a database. So this is the same thing I just went through, it just has bigger numbers. So originally people didn't even add salt, but now now they do, just because that way. So the reason for salt is because that way if two of us have the same password, right? My salt would be 1357, yours would be 2468, and therefore our numbers would be different. Our hash numbers would be different. If we literally had exactly the same, then if somebody knew yours and they could see that our hashes were the same, they would know mine as well. Because remember, this function makes the same output on the same input every time. That's required. So this allows people to have the same password and have a different hash. And there's no way to tell that those would be the same, that these would be completely different. They wouldn't even be partially similar. So that's the reason to add salt. So here is a real world example. Say my password is elephant. Here's some randomized salt. You can stick it on the beginning or the end, it doesn't matter, or both. Here is a hashing function, an open source hashing function. Get to that in a second. And this is what it outputs. Right? So all I have to store in my database is this and this. And I would like to see you try to guess elephant from the combination of this and this. If you could do that, I have a friend at the NSA that would like to talk to you. All right, so then to check your password, all I do is you type something in, I stick this on the end of it, and put it in the hash. I check whether it matches this. Super fast, super easy, super secure. Here's the Python code for it. All right, input, what is your password? This creates a guaranteed unique salt. So UUID function means universally unique ID. I don't remember how long it is. It's probably that long. So, right, lowercase 26, uppercase 26, numbers 10, symbols.
Is this everything ASCII or what?
Yeah.
So
Well, no, not quite. Let's say let's just pretend there's 75 possibilities for each character, and however many that is. So 75 times 75 times 75 times 75 times 75, right? There's a lot. It's guaranteed unique. You're never going to have two people with the same salt, right? So then I just print password plus the salt, and then I use an open source method. The SHA512 creates a 512 character hash. And if you remember nothing else from this lecture, do not write your own encryption algorithm. Please, I'm begging you. Until you have to do it, if you take a security course, You are not as smart as everyone. Right? Open source is everyone. Right? You might be smarter than most people, but the people that have written this, and then everyone that has looked at it, and everyone else that has looked at it and tried to break it, right? All combined are smarter than you. Just trust me on that. Okay? Do not write this yourself until you have to for a course, and then never write it again, because you are not gonna do something that's secure. So basically all this is saying is use the hash library, use the SHA-512 algorithm to encrypt the password plus the salt, encode it in ASCII or in UTF-8, same thing really, and then just store it in hex. So these are just ways to make it storable in our database. This is not security, this is just encoding, right? This is the secure part. And you can look up all sorts of different hashing and encryption algorithms yourself. And you can run this program, I hope you will. All right, so for Thursday, this is your assignment. It is already in D2L and in GitHub Classroom. The GitHub Classroom assignment is just a blank, or not a blank, it is just a README file because I don't know what language you want to use. Every language, Java, PHP, JavaScript, Python, all have open source hashing libraries. You do not need to write any of this yourself, right? All you have to do is ask the user for their password. You don't even need a username, right? So all I want you to do is have some kind of prompt. I don't even care if you say, what is your password? They type in whatever they want, right? It stores this, salted and hashed, and then it asks them again to type in their password. And they type something in, it says wrong. They type something in, and it says right.
So it keeps asking until they type it in right?
Whatever, I don't care. No, that's a reasonable question because I could be, testing it with an automated method, but I'm not. I'm actually gonna look at your code to make sure you're salting and hashing. So I don't care how you do it. I just want to see you ask the user for some text, salt it, hash it, store it. Ask the user for some text, salt it, hash it, compare it. That's it.
So you're basically just comparing the hashed text.
To what is in the database.
Yeah.
Yes.
Do you want us to make a new database for that or use our...
Don't care. Don't care. Might be easier. Any other questions before I start helping people? Yes, you can do first.